Okay, hello everyone. Good morning. Bom dia, bonjour, buongiorno, dobry dzień, assalamu alaikum. And welcome to this new and last webinar organized by Ocrim. My name is Anna Buffa. I'm a food entertainer and I work in communication field since 15 years. And today I'm going to moderate this webinar. It will last 1 hour, and during this time, you will be able to ask to the speaker questions just by accessing to the form you find in your computer and typing your question. The most complex question will be answered by mail, and you can write everything you need to answer more complicated just by writing to conferenceroom@ocrim.com. Questions are anonymous, so okay, don't be shy, ask whatever you want. Today's topic is about pneumatic system in the HEF and the flour silo aspiration to preserve low as flour. And it's going to conclude the third and last part of technological tips. I'm very glad to leave the floor to Mr. Marco Galli, our Ocrim chief technologist, who started his career in 1983 as miller apprentice. In 1993, became Ocrim technology master in Bogasari flour mill, the largest milling plant in the world. In 2006, became technology headmaster of the Ocrim Milling Technology School, and in 2013, managed and designed the milling hub in Cremona. He's very popular for his patented inventions filed by his name. So I'm very glad to leave the floor to Mr. Marco Galli, and we will talk very soon after the first part of the presentation for the first time for the question. So welcome, Marco.
Thanks, Anna, and good day to all. As already briefly mentioned by Anna, today we will just resume some tips that we shared with you on the previous section, with the goal to share with all the participants the approach that Ocrim has on a flour mill to produce as much as possible the low ash flour. But today we will go a little bit further on that one, because one thing is producing flour, another step is how to manage this flour and how to keep the value of this flour along all the process that we have. So this will be the topics that we will see on the next during this webinar. So starting from where we discussed, we share in the previous webinar, we're talking about granulation range and a concentration of this granulation in order to achieve higher extraction percentage in the low ash. We're also talking about the SIR concept. What means SIR concept? Is the concept that we apply to the flow sheet in order to use the roller mill to improve the stock quality or to improve the product quality. So these are the two concepts that we just shared on the previous one, with always the goal to obtain very low ash flour on the higher amount. This is something that in certain markets, the higher production of low ash flour is let's say, is a benefit that the mill has to have in order to increase their economical balance. So is paid a premium for that flour. So in this condition, we develop a dedicated flow sheet to that one. On top of that, we want also to drive some tips related to some, let's say, layout or engineering solution that can help on better maintain and handling the flour during this passage. So those will be the two concepts, the pneumatic system, how to manage the pneumatic system to obtain or to even increase the low ash flour. And in the second part will be the silo aspiration, also to preserve the low ash flour, because it's very easy to lose part of the flour that we produce if we don't make the properly choice. Let's say that starting from what we say, just introducing or the concept recall, the aim of the high efficiency flow is to keep products segregated based on quality and granulation, and also to introduce the SIR concept. Both this concept, SIR concept and product segregation, in order to obtain low ash flour as much as possible. So this is the first goal. This segregation is based on ash content. When we say all through the presentation, all through the webinar, when we say quality, we means ash content. So ash content is the driving from our quality aspect. These two concepts, together with the optimum extraction on flour, on low ash flour, is because in certain market, and we are seeing that is a tendency that is going up in all around the world, is because low ash flour or premium flour has a premium price. So mills are looking for this premium price in order to have more margin, to economical benefit. Of course, to have a premium flour or low ash flour, we have to be very careful on cross-contamination. We know that if we mix two different products with different ash content, of course, we are not able anymore to divide this product and having again cleaner product in order to obtain cleaner finished product. So cross-contamination is one key point if we want to optimize low ash flour extraction. Cross-contamination can be in the product, but there are some passages through the mill, let's say some sections through the mill that is today a contaminating point. One of these is the pneumatic system, because the pneumatic system is conveying both cleaned product and dirty product. And the combination of this on the dusting that goes to the filter is something that is contaminated, which we cannot, on the today's technology, we cannot obtain any added value from that. Considering that the part we are is going to be separated by the filter from the pneumatic system is about 1.5%. It's a small number, which today is just sending to the end of the mill and say, okay, we cannot do nothing with this product, so we cannot create value on that one. But it's not like that. We would like to show you how you can obtain value from this product. Before to have this point, we will share also a screenshot of the flow sheet just to show where we concentrate product passages in order to obtain the low ash flour. And this is important in our concept because this is something that is easily identified and is easily, let's say, concentrated in the layout. Because this concentration also will help us to define a layout in order to obtain this benefit on the solution that we will show and present to you. On this next page, we will see how much low ash flour we can obtain in our system together with this concept that we apply on the high efficiency. But we still having space to improve these numbers, avoiding the cross-contamination that we can get on the dusty product from the filter. So in this case, what happened? We can increase, or in other terms, we can reduce, because if we are contaminating this product, the product that we have in the filter, we cannot have the maximum extraction. So we will, in the end, affect the economic balance of the mill. So the question today is, what is the a technical solution that we can apply in order to optimize the flour extraction on low ash flour. So this is what we will be talking in the next slide. And here is the Ocrim solution. As you may see, the Ocrim solution is dividing the single pneumatic system into a different pneumatic system, each one dedicated to the specific product. So we will have one pneumatic system dedicated to the low-grade products, which is product high in ash, and the high-grade product, which is the product related to the low ash. This simple division or splitting will allow you to have a lot of benefit that we will be discussing and sharing in the next slide. One important aspect before this evaluation is that the division between one or the splitting in two pneumatic systems will have different impacts. Will have impact in the flow sheet, but as well will have impact in the layout. So it's important to consider in these two aspects. And we will analyze, even under economical point of view, the impact of the splitting between one and two systems. But let's summarize, or briefly mention the benefit, the pros and cons that we have related to this system. If we have divided in two subsystems, as we mentioned, we have a pneumatic related to a cleaned passage. So this will be dedicated only to the passage which low ash contain. And this will allow to recover the product that we collect in the filter and be processed inside in the same group. So we will not lose any cleaned product due to the cross-contamination. On the other hand, if we have, with the second system, we will manage all the dirty passage that we have in the rest of the mill, which will not impact anymore our premium flour, our higher quality flour. Why we came to this solution? I think it's easy to understand just to make this small example. If we combine C1 product from C1 and product from B5, of course, the quality will drop. We will compromise the finished quality of this combination of product. So we will have better B5 product, but not enough to have low ash flour. And we will drop the quality of C1, making this product not anymore able to have a low ash flour. So this is the cross-contamination which we are considering. And this we have in the ducting, in the pneumatic ducting, which will limitate the possibility to have this flour. Considering that the amount of all this product is about 1.5% of the capacity of the mill capacity. So it's a small number, but along the time can be even important. Keeping this passage segregated, so we will maintain the integrity of the product, the cleaned product, and in the end, we will increase the extraction that we will have. The low ash pneumatic system, okay, will have in the end the scope to maintain the ash values of the cleaned product and maximize the recovery of the flour. Depending on the capacity of the mill, depending on the flow sheet, we can increase or reduce the number of passages under this low ash pneumatic system. But to summarize briefly, the low ash pneumatic system will be concentrated in the head of reduction and in the head of the sizing passages. So here we can say size 1, size coarse, medium, and fine, second size, and then C1, C1A, B, those. So the head of this part which is producing for us the best quality flour that we can obtain. Now, the question is, when and this system will have a paying back. So we see that we have benefit on using that system, but the benefit that we have will overcome the higher cost that we will have on following this solution. And the answer is yes. So we have economical advantage that will cover the higher cost of this system, the investment for this system. And in the next slide, I would like to share with you some analysis, some data that we develop together with customers in order to understand how much this benefit is, especially when we have a premium price for low ash flour. But before to come to economical numbers, let's see what is the impact. Then one solution, so a single filter versus two systems. Let's say a single filter, a single system versus two systems. So first of all, in the two systems, we will have little bit more square meter for the filter. So you will have more surface on the filters because compared to one single filter. The second one, splitting also the fan, because when we say two separate systems in one solution compared to one single system, we are mentioning everything: filter, fan, ducting, which is totally splitted. So we will have more filter area and more installed power in a fan. And this is the difference. We will have a delta about 14% on the filter area and about 10% on the kilowatt installed power. But on the other hand, we are mentioning that we have more. But really, having this more filter surface, more power on the pneumatic fan, is that one really a negative aspect? Just considering maintenance. I personally don't feel that having higher filtration surface is a negative aspect. This can postpone your maintenance because your filter will working on better condition. The same for the pneumatic power. We know that a little bit more power in the pneumatic will be sooner or later payback, because in the critical moment you can boost your system in order to have a better performance. But now let's go to the number and to the assumptions in order to have this the final numbers. So let's assuming that from this splitting we will recover about 0.5% more flour. Okay, so this will give us 0.5 more flour. Considering a difference between the standard flour or all-purpose flour against the special flour or premium flour, about €100 per ton, considering a mill with a capacity of 400 tons. So computing these numbers, we will have about 2 tons per day more flour. These 2 tons per day more flour will be €60,000 per year, based on 300 days, on final incoming that we can have. €60,000 per year is a value that will cover for sure the splitting of the system. And then all the next years will be a value that will allow to have a better total cost of operation. So we are saying for a very simple solution, which is the splitting of the pneumatic, which will allow you to have an incoming for the rest of the life of the mill about 50, 60,000 euro per year. Of course, depending on the regions, these numbers can be a little bit more or can be a little bit less. But this is the return that you will have. So with a simple solution, you can have this kind of, this amount of return of investment, which allows you to be even more competitive on your market. So with this one, we finish our first part of webinar, and let's see if we have some question related to this part of the presentation, let's say. Anna, it's your turn. Yeah.
Yes, we have a couple of questions right now, till now. The first one, do exist plants in operation that already adopted this system?
Yes, and the plants that adopt this system, and from where, honestly, we start with this idea, are in Asia. Because in Asia, they have a very big market for the low ash flour. So we developed this solution in order to increase as much as possible the extraction of this flour. So the payback and the benefit are recognized already from certain clients that they are using this system. So the answer is yes.
Yes, thanks. Can we adopt the pneumatic solution also for those systems which don't use the HEF concept?
The answer is yes, because this is a concept that is linked to the high efficiency flow, because the high efficiency flow is a concept to optimize the low ash flour. But if the customers feel that they can have a benefit on splitting the pneumatic system because they have a certain type of flour that has a more margin or has a more value for them, this can be done. So this is not exclusively combined to a certain flow. This is something that can be adapted to any mill's requirement, is adapted and is suggested when millers has a certain high quality flour. Doesn't mean if it's low ash flour or is whole wheat flour for a certain passage. If they have a premium flour that the market wants, the markets are able to pay more for that flour, this system can be used.
Okay, and having two pneumatic systems, how does impact on maintenance?
Okay, theoretically, it impacts a little bit more than have one pneumatic system. But as normally I like to say, it's important to see the overview package. Because if you see just a single point, then you may be take out from the real situation. So if we have one pneumatic system, this pneumatic system will be bigger. Then we have to have bigger filter and so on. If we have two pneumatic systems, we have for sure more equipment to follow. But as we saw before, we have more filtration air surface. This means that I don't need the same frequency that I need with a single system. So if we start to considering the less frequency, which will combine the little bit longer time to make this maintenance, I think in the end of the day, honestly, the difference is minimal, you know. And also having the system split in two, you can decide how many time to dedicate to this job. So you can, instead to use 3 hours in a single shot, you can say, okay, let me do one first job, one part of this job in 1 hour and dedicate the second hour and a half for when I have more time to do it. Instead, on the single system, if you decide to stop, you have to stop for longer because the machine is one single machine is bigger. So there are pros and cons, but in the end, yes, there will be a delta, a minimum delta on maintenance on the two systems compared to one, but it's not this huge difference as you may thinking.
Okay, we can go on because for now this question are okay. Thanks.
So the next part of the webinar will be how to managing the flower, because we always considering how the flow sheet produce this flower, but sometimes we forget to optimize all the system that manage this flower. And this is the reason why I want to spend a couple of this last half hour on talking about the flower silo and how the flower silo can impact the quality of the product or can compromise the product that you produce in the mill. So this is the reason why I want to share with you some concepts that we apply in the silos design in order to maintain the integrity of the flour we produce in the mill. And in the silo, especially considering the aspiration, because the aspiration in a flour silo is one of the, if it's not the real critical, is one of the critical points. But before then go in details on that one, let just refresh ourselves on the flour silo. What are the concepts that the flour silo has to adapt based on the design? So what will be the concept that we have to consider to have an appropriate design? We are saying the flour silo and beginning of the development of the flour silo, we need to know the different products that the system has to process simultaneously. Different products need different concepts. Similar product is easy to process. Conveying system, we will go for mechanical or we go for pneumatic, because mechanical is easily managed by aspiration point of view, but could have problems related to the contamination. Pneumatic is more complex on the aspiration because we have a higher volume that has to be managed. Prevention of any contamination, and this falls down in the conveying system or also the aspiration. Another important aspect is the simultaneity. Simultaneity is about the recycling. So what happened in the silo in the meantime? This, again, connecting to the aspiration or to the conveying system. Then we have the flow rate capacity of the product. Flow rate capacity means is linked to the conveying system, which conveying system is if pneumatic, and then we have to manage the capacity, the air volume. So bigger is the capacity of the lines, bigger will be the volume, the air volume that we have to manage. Then the last but not least, the standards and the regulations. Of course, there are countries where there are certain regulations that we cannot, that does not allow us to apply all the solutions that we can have. So we have to consider in all that one. And as we mentioned, mostly all these passages, all these steps are linked together through the aspiration system. So we have to properly understand all these aspects in order to understand what aspiration we have to set in order to prevent any contamination. Based on this, we have divided in three independent, in three system philosophy or three philosophies, the aspiration that we can apply to the flour silo. And the systems are basically three: centralized aspiration, independent aspiration, and combined system. Now we will go very fast through this system, showing the pros and cons of each one, but also trying to understand and comparing the first two, the centralized and independent, also by economical point of view, considering the benefit that one has compared to the other. Okay. Always please remember that we have to considering these three systems based on what we want from the flower silo. So starting from the centralized aspiration system, what we mean for centralized aspiration system is a aspiration obtained by one single system. When we say one single system, we are saying one filter, one fan, and a single manifold that will reach all the aspiration point that we need. So will be a just bracket manifold everywhere in the flower silo, reaching the single points. So this is what we mean for centralized aspiration. Then the aspiration simultaneously is guaranteed only in the point foreseen for the simultaneously and for the active cycles. So the other points which are not involved on a specific cycle are not aspirated for that specific moment. This brings us one key point, which is the correct identification of cycles. Because if we need aspiration, but the cycle does not foresee to aspirate in that point, in that specific moment, it will be a problem. So it's important in the design phase, evaluate all the aspects, evaluate all the single points where we need for the simultaneously and the aspiration point that needs to be open. How we divide it, how we segregate the parts where we need air in certain moments and the parts where we don't need. Through butterfly valves, which is open or closed part of the system. And this is how we considering the centralized aspiration system. Pros and cons. So we have the first aspect is we have to be able to manage different points, okay, according to the sequence foreseen. Different points means different point by quantity of air, different points means by distance. So just from these two aspects, we understand how difficult. Sometimes we have to aspirate higher volume, sometimes we have to aspirate low volume. So the system has to be able to manage this one. Then we have the problem to manage the residual product that we collect by the centralized filter. When we say the residual products, we mean that the dust that we collect from the aspiration. If, for example, if we have two systems runs together, it's the same concept that we have on C1 plus B50. So we have the higher risk on contamination. Then we have a periodical filter maintenance because the maintenance of the filter is more frequently. And when we have a maintenance on this filter, we have to shut down everything. So this is another aspect. The future change, if we have to change the cycle, if we have to change it simultaneously, then could be difficult. Of course, the system is difficult to balance. Just imagine to aspirate two different moments, higher volume, low volume. This is quite difficult to compensate, okay? And is logically also. Flow rate, and this is the example as before. If the flow rate is not always constant, we have different cubic meters, so air flow rate, which will impact your system. On the other hand, this is a system very easy to be used when we have very few products. The air volume of the aspiration are very similar, so we have no differences on that one. So it will be very, very simple on that point. The question in the end is, the idea is, this is a simple, is a economical system, but really is like that one. If we considering the higher cost of electrical installation, if we considering the low quality, the potential loss that we have, the higher maintenance, high in the parts that is involved and in the energy cost. So if we put all these aspects together, I am not so convinced that that is an economical solution, but it's just apparently solution. Other aspect that we have to analyze to understand if this is a really suitable system for your need is the regulation and standards. Sometimes the regulation does not looking properly if we aspirate with single system. Then we have the reintegration of the dust recovery, which is a downgrade, could be a downgrade of your product. And in our case is a critical point, which has a negative impact even in the turnover of the mill. And here is the comparison with the low ash flour. In this case, the low ash flour that we are blowing in the centralized system will be downgraded, especially on the dust that we recover. So this is a real problem on the field, on the flour silo. What we can suggest as to conclude the centralized aspiration. This is a solution that is mostly common used, as I mentioned. There is let's say, idea that this is cheaper. So due to that one, people are trying to use that one. Can be used when we have a silo without excessive complication. When we don't have, we are not concerned about the remarks that we are talking about, and when the flour types are not so diversified. So if we have a single type of flour, there is no problem on using this type of silo. Then the alternative. The alternative is the independent aspiration. It is the most common and is picking up on today's technology because it's more flexible, because we don't have any contamination risk, because we can easily install, because we can manage even very high volumes of air, okay? And normally we find this solution applied to the load of the beans, but can be also utilized on scale, can be also utilized on hoppers. So it's very flexible system and easy to be utilized. Now, going in the details and the pros that we see on this one, we can preserve the quality of the product even if we have different product moving inside in the silo. So there is no cross-contamination. And this is the only system that allows you to guarantee no cross-contamination. Of course, for regulation and standards, this allows you to have, is the only system that allows you to have isolated connections between the different systems, and aspiration is a cleaner solution because with a simple filter we can have a reliable aspiration without going through dust and things, ducting and so on, which makes difficult also to cleaning and to properly maintain the system. And in the end, we have lower cost both on energy and maintenance. Briefly, maintenance, because the filters are, the working hour are divided in more filters. So we extend the time. Lower maintenance costs because we don't need to stop all the plant, but we can do maintenance in the single point. And the energy, because we don't need to run a big fan even for low volume of air. So this is the benefit. In then summarizing, this is the evaluation that we have. Working time is limited for the operational time, so we will extend the total working time during the years even. Is not necessary the total shutdown. Is reducing the condensation, because condensation is one of the biggest problems that we have. But this system, due to the single point aspiration, we reduce the condensation. Less energy because we are running small motors compared to one big motor for all the system. And on the other hand, we have a little bit higher investment. But let's see, because the question is not how big is the investment, is how long it will take to have a payback on this investment. And this is some assumption, of course, because there is no a direct number. And considering that we don't have any contamination, and this is already a plus, considering that we preserve the low ash in all the process, this passage, this is another plus. So putting together all this and assuming that we will recover about 0.2% of low ash flour or premium flour due to this solution, the final computing show us about 12,000 years per cycle. In this example, the cycle that we're considering was just the one blowing the flour from mill to silo. So just blowing the low ash flour from the mill to the silo with this system will allow you to save about 12,000 euro per year. Imagine when you start to moving the flour inside in the flour silo. So to have the next step, which is the pros and cons and summarizing, we have a single system and a simple layout. Easy handling, because working with the single aspiration point make everything more simple. Higher flexibility, no cross-contamination, reducing to the minimum the maintenance cost and the running time. Altogether, for sure, will cover the initial higher investment. This is what we're considering. Of course, there has to be a premium flour to protect. Otherwise, there is no logic on working on that one. Then we have the third part, which is the combined aspiration. The solutions, they are not always white and black. We have always some compromise. We can obtain some compromises. And let me say, this system fits perfectly when we have a premium flour, which is not important part of your business. So you can dedicate it for certain beans, a individual aspiration, which will allow you to preserve your product. And then the rest of the system could be centralized one where you don't recover any more product. So this will allow you to have a more compact aspiration, well-performing premium flour with an independent aspiration system, and we will combine the best of the two filters and the two systems with, let's say, reducing the initial investment cost. To close the presentation, let's just spend a couple of words in the related to the single filter. And the single filter is standing on the single point where we will aspirate it, is similar. The working principle is really similar to the traditional filter. There is an integrated fan which makes this equipment as a single equipment, so plug and play equipment, easy to install in every point. The back pressure is through the air compress. Normally, we supply filters in stainless steel due to the food safety and concept, because we are using these filters in the flour silo managing finished products. So it's a continuation of the food safety concept. All the frequency and the cleaning cycle is managed by electronic panel, and in order to save the energy, the back cleaning happens only when you exceed a certain drop pressure. So it's useless to clean sleeves. So this is what we develop in the electronic panel. So now we are to the conclusion, and I would like to conclude saying that it's important to take care about all the process, not only in the flow sheet. Flow sheet is one part, we see flour silo is another part. So it's important to have all the process under control and handling all the phases in order to prevent the finished product. It's very easy to lose percentage or to lose part of the quality product that we have produced in the mill with an incorrect plant design, okay? And also another point, which for me is important, is easy to say that one solution is cheapest, but we have to have an overview to really understand if we are going for the cheaper solution, not just considering the short-term evaluation, but we have to considering also medium and long term. So in order to evaluate a CapEx to under all the aspects is to make the right choice. In other terms, what I'm trying to say is that we have to understand exactly all the phases in order to evaluate the right CapEx, to make the right choice. Because sometimes that we think together and seems to be cheaper in the long term, as we see, could be more expensive. And the recalling on this one will be really more cost effective. Okay, so with this one, I conclude my presentation. I hope you enjoy this time. If you follow all the 3 webinars, I hope you enjoy this trilogy. And most important of all, I hope some of these tips could be used in your working life. With this aim, this was the aim of this webinar. So if we obtain that one, I will be glad. Now, Anna, if we have some questions, we can
yes,
go
we have
with
a couple of, yes, we have a couple of questions. Can you please focus a little more on the reduction of condensation in the flour beans?
So condensation happens when we have hot product in the cold area. Normally, the flour coming from the mill is higher in temperature than the temperature that we have inside in the beans. So blowing there, also due to the hotness of the air to blowing the flour to the beans, we have this air, hot air and product, which could create during the time this condensation, or at least this atmosphere, this environment where the condensation can propagate during the time. through the single aspiration point, we can do, let's say, we can recycle the air periodically, just starting and stopping the filter for a few minutes. This will create an air movement without unbalancing any other parts of the flower silo, allowing you to have a properly environment inside in the beans. And this, believe me, is really important because condensation, especially in the countries where we have a very big difference temperature or humidity during daytime or night or summertime or winter, this could be a solution that helps you to maintain in a properly condition your plant. We say there is no a magic equipment that helps you to maintain in good shape your facility, but is the a combination of many single and small steps. This is one of these small steps that will allow you to have a better environment inside of your bean.
Okay, when you use a single solution for the filter in the flower silo, what happens after the filters? Do you use single pipe to send the air outside, or do you collect all the filters?
No, normally we can do both. We can collect the air coming from the single filter together and send it to external. We can, let's say, convey this air with the ducting to outside. So it's depending. Mostly today is using the air collecting together with the ducting to outside. Okay, this is the most, let's say, the most used solution.
Okay. Why is the individual aspiration system more energy saving compared to the centralized system?
Okay, I will give you two numbers to make more clear the concept. If we calculate the single point, the centralized aspiration, we have to consider it. We have to size the aspiration for the highest simultaneously. So we will have for sure flower coming from mill to the silo. We have to aspirate those points. Then we have to consider in some recycle. So the system has to be sized also for that one. Then we have to considering the deliveries. So the flower that we move from the silo to the packing, load out, and so on. So we have at least three points that we have to calculate and sizing the fan. We have to sum to make the total consuming air for this one, which will be, and in the end, we are not sure that we have all these three systems working at the same time or always working on the same time. So let's say if I have 5 kilowatt for each of this system, I have 15 kilowatt, which are running maybe just one. So I have a fan sizes for 15 kilowatt that are running just for 5 kilowatt. This is the reason why I'm saying is energy saving having the single filter comparing to the centralizing aspiration. Just an example, then we can go more in detail, but this is just to give you an indication on how we considering and how we say why one system is more energy saving than the other.
Okay, I would like to thank you for your attention, and I hope you enjoy these webinars. They were very interesting also for me. So thank you very much. Follow us on our website and in our social pages too, obviously. And so thank you, Marco. That's enough.
Thank you to all again. And we keep in touch for any further clarification. Just email to the email that we share. All the best to all and Merry Christmas to all.
Thank you all. Bye.
Bye-bye.